Before we go to our lesson proper of 10-2, let's take a look at 10-2A first, factoring using the distributive property. So this is just a preview of 10-2. We will need algebra tiles and a product math for this one. So when two or more numbers are multiplied, these numbers are factors of the product. Okay, sometimes you know the product of binomials and are asked to find the factors. This is called factoring. Again, definition of factoring. Okay, you know the product of binomials and you're asked to find the factors. So we want to find it using the method of factoring. You can use algebra tiles to factor binomials. And let's take a look at the activity number 1. We want to factor 2x plus 1. This is a binomial and we want to find the factors of 2x plus 1. So first things first, model the polynomial 2x plus 8. So if we model it, it looks something like this. 2x tiles and 8 unit tiles. And step number 2, arrange the tiles into a rectangle. Okay, so the total area of the tiles represents the product of its length and its width. Okay, represents the factors. So again, your area would be, first arrange them into a rectangle, and this is your rectangle. And if you notice, after it has been arranged in a rectangle, the width of this rectangle is 2. Why is it 2? Because this is 1 unit right here, and there's another unit right there. Okay, and this is x plus 4. Why is it that? Why is that? Because this is x right here. This is 1, 1, 1, and 1. So that's x plus 4. Okay, so if you notice, okay, this rectangle has a width of 2 and a length of x plus 4. Therefore, 2x plus 8, okay, has factors of 2 times the quantity x plus 4. Okay, let's look at activity number 2. Use algebra tiles to factor x squared minus 3x. Again, we need to model the polynomial x squared minus 3x. And that's one big x squared tile and 3 negative x tiles. Okay, step number 3, 2, just like what we did in in activity 1, we arrange them into a rectangle, such like so. After you arrange them into a rectangle, we now have the dimensions x, because this is x right here, and that's the reason why it's x. This one's x minus 3y, because this is x. This is minus 1, and minus 1. So it's x minus 3. Okay, therefore, in this case, the rectangle has a width of x and the length of x minus 3. So the factors of x squared minus 3x will be equal to x times the quantity x minus 3. Okay, and let's do a little bit of exercise here. Use algebra tiles to factor each binomial, and I copy these binomials in the next page right there, top. So these are our algebra tiles. Okay, and we want to model x plus 9. Okay, so we have, sorry, not that one. Let me undo that. We don't need that. Okay, so x plus 1 plus 9. So if we want to model x plus 1 plus 9, so we have 1 x tile. Okay, and then we simply put 9 units there. Okay, so 3 sorry, 3 x tiles. 1, 2, 3 x tiles, and 9 unit tiles. So 1, we just put all the 9 there, then I'll fix it. 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we now bring in to fix all of them. Okay, I'll make it as close to a rectangle as possible. Yeah, that's close enough. So if you notice, in this particular algebra tile right here, okay, the width is 3 units, because that's 1, 1, and 1. Okay, and this one is x plus 3, 1, 2, 3. So this is x plus 3. Okay, so the factored form of 3x plus 9 would be 3 times the quantity x plus 3. Okay, let's do example number 3. So it's going to be a lot shorter. Sample number 2 is a very sample exercise number 2 is very similar to sample exercise number 1. We'll do sample exercise 3 and we're good to go. Okay, so let's delete this first. Then let's do that. So we have 3x squared plus 4x squared. 4x, that means we have 3x tiles, x squared tiles, 1, 2, and 3. We want to make it smaller because we want, I think it'll fit. No, it won't. Let's make our x squared smaller. So it'll fit our algebra math. You know what? Let's do it normally because I don't feel like shrinking all of them. So you have 3x squared tiles, 1, 2, and 3. And then we get, let's move this here. So we have space, 1, 2, and 3. And 4x squared tiles, 1, 2, 3, 4. Okay, and if you notice, okay, the width of this rectangle right here is x, and the length is, this is x, and 1, 1, 1, and 1. So this is 3x plus 4. So the factors of 4x plus 10 would be x times, okay, sorry, we're here, x times 3x plus 4. Okay? Okay, let's jump to our lesson proper, which is 10-2, using the distributive property. And in this lesson, you'll use the GCF and the distributive property to factor polynomials and to use grouping techniques to factor polynomials with 4 or more terms. So we start factoring the factoring proper, okay, and this is basically the foundation of a lot of algebra lessons. You will use this in geometry as well and in calculus in high school. So the faster you master this, the better off you become. Okay, so let's take a look at this real world example in sports. Rugby is a contact sport in which each of the two teams tries to get an oval ball behind the opponent's goal line or kick it over its opponent's goal. It is similar to American football. However, the action in the game is almost non-stop, and the players wear little or protective gear. There are two variations of rugby: rugby union and rugby league. Rugby union is popular in Australia and Canada, England, France, and Ireland, Japan, New Zealand, Scotland, Africa, and Wales. It is played on a rectangular field. Okay, so this is a rugby field right here. If the width of this field is represented by x, right there, okay, and the length can be represented by x plus 75 right there, and the area of the field by x times quantity x plus 75 or x squared plus 75x. Okay, so the area is the product of these two, which is x squared plus 75x, is if x times quantity x plus 75 equals x squared plus 75x, then x squared plus 75x equals x times x plus 75y. Simple answer would be because of the distributive property. Okay, and this is the factored form of x squared plus 75x. So x times the quantity x plus 75 is a factored form of x squared plus 75. So a polynomial is in factored form, okay, when it is expressed as a product of monomial and polynomials. Definition of factored form, write this down. Okay, it is in factored form when it is expressed as a product of monomials and polynomials. Okay, so let's see if I can write this in a straight line. Okay, so it is in factored form again if it is a product of monomials and polynomials. Hey, that looks a lot better. There you go. Okay, so in chapter 9, you multiply the polynomial and a monomial using the distributive property. You can also reverse the process and express a polynomials in factored form by using the distributive property. And let's take a look at this first model. The area is 6a. Okay, therefore, the width of this area is 6 and the length would be 2a. So if I multiply 3 times 2a, that would be 6a, and 3 times b would be 3b. So multiplying the polynomials, now I have 3 times the quantity 2a plus b right here is equal to 6a plus 3b. Okay, so factoring polynomials, 6a plus 3b therefore is equal to 3 times the quantity a plus 2b. We simply switched it. Okay, so let's take a look at model number 2, where the width is 5x and the length is 3x minus 4y. So that means if I have these two rectangles, the area of this rectangle would be the product of 5x plus 3x would be 15x squared, and the product of this rectangle would be the product of 5x times negative 4y, or negative 20x y's. So multiplying the polynomial, we have 5x times the quantity 3x minus 4y is equal to the product is equal to the area, which is 15x minus 20xy. And if we want to factor it, we simply switch this. So we now have 15x squared minus 20xy is the same as 5x times the quantity 3x minus 4y. Let's take a look at the last model, wherein the width is 3 and the length is x squared plus 5x. So if you notice, 3 times x squared would be 3x squared, and 3 times 5x would be 15x. Okay, multiplying the polynomials, I have 3 times the quantity x squared plus 5 is equal to 3x squared plus 15x. So if I want to factor the polynomial, I simply do the reverse. I have 3x plus 15x is equal to 3 times x squared plus 5x. Okay, so that's the factored form of this particular polynomial. Again, it is considered to be in factored form when it is expressed as a product of a monomials and polynomials. Again, product is important. Okay, the word product, if it's not a product, it is not in factored form. So it has to be a product of monomials and polynomials. Okay? Let's take a look at example number 1. Not example number 2, example number 1. Factoring a polynomial or finding the factored form of a polynomial means to find its completely factored form. So in the expression 3 times the quantity x squared plus 5x above is not considered to completely factored form, since the polynomial x squared plus 5x can be factored as x times the quantity x plus 5. Okay, so again, we define another important term here, and then you need to write this down. Let's use red this time to underline it. Okay, so factoring a polynomial or finding the factored form of polynomial means to find its completely factored form. Okay, so that means you cannot factor when you cannot factor a polynomial anymore. It is in a completely factored form. And let's take a look at this one. Use the distributive property to factor each polynomial. We have 12mn squared minus 18n squared n squared. Okay, again, in lesson 1, we talked about GCF. So we want to find the GCF of 12mn squared and 18m squared n squared. Okay, so we use prime factorization or completely factoring them. Okay, so completely factoring 12mn squared, this becomes 2 times 2 times 3 times m times n times n. And this is 2 times 3 times 3 times m times m times n times n. Okay, and then we get the common factors. We circle the 2, we circle the 3, we circle the m, and we circle one of the n's. Okay, so bringing them down once. This is basically 2 times 3 times m times n, or the GCF is, okay, 6mn squared. Oops, I forgot one n. Oh, that's right, I did. Right there, I forgot this n right there. In the black. So I forgot this n right there. We'll do that again. So this n I forgot. There you go. So it's 6mn squared. Okay? Now, we factor out the GCF, which is 6mn squared. Okay? And we put everything back in the parentheses. So basically, that's what it's saying. Notice that 12mn squared is equal to 12mn squared times 2, and 18mn squared, okay, m squared n squared is equal to 6mn squared, which is the GCF times 3m. Okay, again, if you notice, the 2 is the one that hasn't been circled right there, and the 3m, again, okay, are the numbers that haven't been circled in 18m squared n squared. Okay, so what happens is that we factor out the GCF, which 6mn squared, and then we simply, okay, we simply add them. Okay, so if we have this 12mn squared minus 18mn squared, we factor 6mn squared times 2 minus 6mn squared times 3m, and then using the distributive property, we now have 6mn squared times the quantity 2 minus 3m. Okay, so that is how you completely factor 12mn squared minus 18m squared n squared. Again, first find the GCF and then put everything in the parentheses, in this case 2 minus 3m. Okay, let's take a look at letter B. 20abc plus 15a squared c minus 5ac. Again, we completely factor each monomial. Okay, so completely factoring each monomial, you now have 2 times 2 times 5 times a times b times c. This is 3 times 5 times a times a times c, and this is 5 times a times c. And then we circle our common factors. In this case, it's only 5 and a and c. Okay, so our GCF, okay, our GCF would be 5ac. That's our GCF. Okay, and that's exactly what it says here. The GCF is 5ac. And what we want to do is we need to factor out 5ac. Okay, and then if you notice, 4b is what's left in the first row. 3a, it's what's left that has not been circled in the second row. And 1 is what's left that has not been circled because everything has been circled. So 1 is in the invisible number here. Okay, so 1 is the only one that has not that has not been circled in 5ac. Okay, if all the numbers are circled, all the variables are circled, then you simply put the 1 there. Okay, then what we do is get 4b, 3a, and 1, and then we simply put them in the parentheses. This becomes 4b plus 3a minus 1. And we factor out 5ac using the distributive property. Okay, and that's how you factor 20abc plus 15a squared c minus 5ac, okay, using GCFs. Let's take a look at example number 2. Example number 2, factor a polynomial can simplify computations. The Lopez family wants to build a swimming pool in the shape of a figure below. Although the family has not yet decided on the actual dimensions of the pool, they do know that they want to build a deck that is 4 feet wide around the pool. So we want to write an equation for the area of the deck. Okay. And letter B, if they decide to let A be 24 feet long, B 6 feet long, and C to become 10 feet, find the area of the deck. So this is what we're talking about right here, the diagram right there. Okay, and let's look at letter A. Write an equation for the area of the deck. So the area of the deck is simply, you can find the area of the deck by finding the sum of the areas of the 6 rectangular sections as shown in the figure. The resulting expression can be simplified by first using the distributive property and then factoring. So the area of the deck would be section 1, that's our area, 4 times the quantity a plus 4 plus 4, that is section 1. Okay. Why a plus 4 plus 4? Because the width is 4 feet, and the length is a, and then you add that 4, add that other 4. That's how you have section 1. Section 2 is 4 times b plus 4. So you have, again, your width is always 4, okay? And b is right here, the length, add 4 feet. That's why it's b plus 4. Section 3 is simply 4c, because that is 4, which is the width, multiplied by the length, which is c. Section 4 is 4b plus 4, same as section 2. Section 5 will be the same as section 1. And section 6 is basically the same because that's 4 feet in width. Okay. And you have C right here. Okay. Adding the 4 and the 4. And that's how you get your length at 4C plus 4 plus 4. Okay. Simplify that further. You end up with that one. And then simplifying further, combining like terms, you end up with 8a plus 8b plus 8c plus 125. And using factoring by GCF, we find the GCF, which is 8 for all of them. And we factor it out, okay? And we're left with a plus b plus c plus 16, okay? So the area of the deck is 8 times the quantity a plus b plus c plus 16 square feet. Okay, so would dividing the deck into different sections result into a different answer? Okay, that's a good question to ask, and the answer, of course, would be not really. Okay, and then letter B, we simply replace A with 24, B with 6, and C is equal to 10. Using substitution, we end up with 448. So the area of the deck would be 448 square feet. Okay, let's take a look at the next one. Before we go to example 3, a lot of examples. We're not done. So example 3, just as it is possible to use the distributive property to factor a polynomial into monomial and polynomial factors, it is possible to factor some polynomials containing 4 or more terms into the product of 2 polynomials. So consider the example 3a plus 2b. Okay, multiplied by the quantity 4c plus 7t. If you use the FOIL method, if you use the distributive property method, you end up with 12ac plus 21ad plus 8bc plus 14bd. So here, the product of 2 binomials results in a polynomial with 4 terms. So how can the process be reversed to factor the 4-term polynomial into 2 binomial factors? Okay, so that's what we want to do in example 3. So let's take a look at example 3. So we have 12ac plus 21ad plus 8bc plus 14bd. Okay, we copy the problem down, and we know that we'll group them first. So 12ac plus 21ad has been grouped, plus 8bc plus 14bd has been grouped as well. And then we want to find the GCF. Okay, we want to find the GCF, but before that, let's read this blue sentence right here. Apply the associative properties is the common factor of 3 appears in the first 2 terms, the common factor 2b appears in the last 2 terms. Basically what it's saying is what I just said. Find the GCF of 12ac and 21ad, which is 3a. find the GCF of 8BC plus 14BD, which is 2B. Okay, if we do that, factor the GCF, factor it. Let's factor out 3A and 2A. So if we factor out 3A and 2A, this is how it's going to come out. If we factor out 3A, you're left with 4C plus 7D. Okay, again, the easier way of looking at this, if the GCF is 3A, so we simply divide this by 3A, end up with 4C. Divide this by 3A, end up with 7D. And the GCF of these two is 2B. If we factor out 2B, end up with 4C plus 7D, because 8BC divided by 2B is 4C. 14BD divided by 2B is 7D. Okay? And then, from here, okay, factor the first two terms and the last two terms. We just did that. And then we simply, okay, 4C and 7D is a common factor. Use the distributive property. So we end up with 3A plus 2B times the quantity 4C plus 7D. So if this is a little bit unclear to you, let me just recall the distributive property. Remember, the distributive property is A plus B, okay, times C is the same as AC plus BC. Okay, so take a look at this one. This is your A, and this is your C, and this is your A, and that's your C. Okay, you're adding them. We want to convert this form into that form. So your A is 3A right there. Okay, your B is, okay, so sorry, that's not an A, that's not. This is your B right here. So your A is 3A right there. Your B is 2B right there. And this, both of these, okay, are your C. Okay, so your C is 4C plus 7D. And that's what comes out there. Okay, so again, we are using the distributive property to be able to end up with this particular factored form of our polynomial. And we simply check by using the FOIL method. If I multiply 3A plus 2B times 4C plus 7D, okay, you'll end up with our original 4-term polynomial. Okay, and this is what we call factoring by grouping. Okay, it is necessary to group the terms and factor each group separately so that the remaining polynomial factors of each group are the same. And this allows for the distributive property to be applied the second time with a polynomial with a common factor. Okay? So, sometimes you can group the terms in more than one way when factoring a polynomial. For example, the polynomial example 3 could have been factored in the following way. So, if you use the same example, we could probably factor this this following way. So, if you have that, you can now group 12AC plus 8BC using the commutative property of addition, and using the associative property of addition, we group them. And then we factor out 4C because 4C is the GCF of 12AC and 8BC. Okay? And once we factor out 4C, we're left with 3A plus 2B. And once we factor out 7, and this binomial, we end up with, we factor out 7D, we end up with 3A plus 2B. Okay, again, once you find the GCF, which is 7D, simply divide 21AD by 7D, you end up with 3A. Simply divide 14BD by 7D, you end up with 2B. Okay, and using the distributive property again, okay, we use the distributive property. We now have 4C plus 7D plus 3A plus 2B. Again, I know this is new for you, so we'll go back to the distributive property, which is A plus B times C is equal to A C plus B D. BC, sorry. And if you notice, this is A C plus B C. Our A is 4C, our B is 7D, and our C is 3A plus 2B. Okay? I hope that makes sense. Right, let's go back here. We know that negative 1 times the quantity A minus 3 is the same as negative A plus 3. And if you notice, if I simply use the commutative property for addition, negative A plus 3 is the same as 3 minus A. Okay, so recognizing binomials that are additive inverses, it is often helpful in factoring. For example, binomials 3A and 3 minus A and A minus 3 are additive inverses, meaning if you add them together, their sum would be 0. Since 3 minus A and A minus 3 will have a sum of 0, okay, so thus 3 minus A and negative A plus 3 are equivalent, okay, are equivalent. So what is the additive inverse of 5 minus y? Okay, so when you talk about 5 minus y, the additive inverse would be, obviously, y minus 5. Okay, so that's the additive inverse of 5 minus y. So how do we use additive inverses in the last example? And in this lesson, the secret word would be New York Knicks. New York Knicks would be the secret word. Secret words. So in example, factor 15x minus 33xy plus 4y minus 20. So first copy the problem down. And we use the associative and commutative properties to group them. So 15x minus 3xy plus 4y minus 20. Okay, so in this case, we just use the associative property. And then we want to find the GCF of 15x and 3xy, which is 3x. And we factor out 3x from this binomial, and we factor out 4 from this binomial. So we have 3x times 5 minus 3y, and 4 times y minus 5. Now, if you notice, okay, in the question, what is the additive inverse of 5 minus y? It's going to be y minus 5. So, what are we going to do with this? So that we can use the distributive property, we simply get, okay, 5 minus y is actually the same as, okay, y minus 5 or negative 5 plus y. Okay, so these are actually the same. Y minus 5 is the same as negative 5 plus y. So if you notice, that is a negative sign there. Therefore, what's going to happen is that this positive sign will now change. This now becomes 3 times 3x times negative 1, okay, times y minus 5 is equal plus 4 times y minus 5. So basically, this problem actually got the additive inverse of 5 minus y, and that is y minus 5. But in order to get y minus 5, there should be you should multiply it by negative 1, and that's what they did. So 3x times negative 1 times y minus 5 plus 4 times y minus 5. Okay, or you can also do it this way, like what I told you. This now becomes 3x times 5 minus y minus 4, okay, times 5 minus y. Okay, both answers work, but let's do this one because this is this is the one that's in the book. Okay, so both of them will work. So you have now, if you use the if you multiply negative 1, this becomes now negative 3x times y minus 5 plus 4 times y minus 5, or simply using the distributive property, that is your A, that is your B, and this is your C. So you get negative 3x plus 4 times y minus 5. And if we want to apply this to this one, this now becomes 3x minus 4 times 5 minus y. Okay, so both of these are actually the same. Okay, and if you want to check, you simply use the FOIL method, and you end up with 15x minus 3xy plus 4y minus 20, and this one too will end up with the same product. Okay, so the last thing in this lesson, In summary, a polynomial can be factored by grouping. Okay, remember this is factoring by grouping in GCF. Okay, if all the following situations exist, so you can use grouping for these situations. Okay, there are four or more terms. So if you have four or more terms, you may use grouping. If you have four or more terms with common factors that can be grouped together. And finally, if you have four or more terms with common factors that can be grouped together, and then the two common factors are identical or differ by a factor of -1. So these are the three situations that must exist for you to be able to use the grouping method for factoring. Whew, and that's the end of our lesson. Thank you for watching.